Okay, everybody, we're gonna start again. Hope everyone's suitably refreshed after the break and took a little chance to enjoy the sunshine. First up, we've got Galen with a description of the talk, which was bunch of stuff, but was definitely fully buzzword compliant. And I'm very interested to see what it covers. So over to you.
I don't know. I don't know if I'm going to live up to the buzzword hype, but I'll be doing basically 3 brief lightning talks combined into one presentation. Hi, my name is Galen Mancino. My GitHub handle is what is Galen. I have a small Archie service provider company called Scholium Technologies, and some of the things you'll see in my presentation are directly supported by the Berkeley Institute for Data Science at the University of California, Berkeley, where I work on a project that I will be telling you a bit about. And just a bit about the title. I guess like search is becoming my brand. I'm just low-key obsessed with it, I guess. But I had a slide in last year's presentation where I showed a pie chart of like what do like graph designers care about, and it's like my data model, my ETL, and like how does the data look, and then what a graph or a pie chart of what do users care about, and it's like 99% search, right? That's what they're doing. They're searching your data. They want to see what you've got. So it's something that I care deeply about as a UX experience and as a developer. So what am I going to talk about? Like I said, 3 brief, basically lightning talks. I'm going to talk a tiny bit about an LLM implementation, proof of concept. I'm also going to talk about this PR I have called transitive search. You can also think of it as a select related search. And last, I'll talk about a project that is outside of the domain of cultural heritage, Arches for a police transparency database. And I'll talk a bit about what is that project, but I'm also going to spotlight a couple of customizations that could make their way into core Arches. They might be interesting to some folks here. So first off, using LLMs for structured search queries. So we speak in plain natural language. And the goal here is to convert that into a structured search query. So unlike a lot of LM implementations that do retrieval augmented generation, where your data is embedded into a vector database, and then that is sort of used as a source of truth for the LMs. In this implementation, it's really just a transformation of natural language into a structured search query. And I'm going to give you a quick demo here that is pre-recorded. It's not going to blow your mind, but I hope it'll kind of get the wheels turning a bit. If you can't see it, it says, show me historic resources in West Hollywood. And it doesn't matter if you know what that is.
But 3 miles away.
Okay, so what just happened? I wrote a natural language query in my native language, English, and next thing I know, I've got a search page loaded with 2 search filters applied: a map filter, it appears, and a resource type filter with 1 result. Hey, that's cool. So it turns out that LMs, surprise, are really good at segmenting the semantic content of plain natural language. So for example, in this green highlighted section, they're parsing the intent, right? What am I trying to do while I'm trying to search? In the blue, it's parsing the entities. And in the orange, it's parsing the relationships. And so Arches is just like so perfectly situated to be taken advantage of, right? We are talking about knowledge graphs that have ontologies baked into the edges. And so if I want to transform this into a structured search query, right, I can just parse the relationships, find the ontological relationships that match. I can sort of match on entity types at the highest level. So what graphs do I actually care about? And if I don't have data in my Arches instance, for example, in this one, temples in northern Libya, I can use externalized references. So the LM, from whatever its training was, might have an idea of what is the polygon that represents northern Libya. It also might be able to create date ranges, EDTF date ranges for when was the Ottoman Empire. So it converts all of these into a geospatial, temporal, and resource type filter. This is something that is currently in progress. So that's the extent of my demo for that. Sorry to disappoint. What's going on? It's prompt engineering. So in this screenshot here, I'm telling it these are the Arch's data types, and these are effectively the advanced search operators that you're going to use. And by the way, here are my graphs in JSON. Following that, and this is a one-shot prompt, by the way. Following that, I'm telling it this is how you build an Arch's search query, and here's an example of what your response should or could look like. And by the way, all major commercial models are trained on the CDOC CRM, so you don't even need to pass that in as context. It already knows what that is. So there's a lot of greenfield territory here, and there are a lot of improvements to pursue. So, for example, what you saw here was from like months ago, and it's kind of crazy how fast things change. There are now more advanced like tools you can use for the structured input and output of data to kind of cut down on the context window, and also better reliability for just getting like a more reliable data export product. Also, Arch's references. So, for example, if I have a resource type called like country, and on that country resource model, I have a country boundary, geospatial field, right? I can leverage those as data sources for my Arch's search filters. And obviously, I'm going to keep working on this because I'm really excited about it. Moving right along. Oh, sorry. One last thing. This is not the only opportunity in my mind for LM-based integrations. So I'm working on something that I don't have a demo for you yet, but it's a speech to graph, right? If I know nothing about data modeling, I know nothing about the Arch's graph designer, I just know I have this kind of data and I care about these fields on each thing. How many things do I have? What are my entities, right? Speaking that to an agent or even just a view, right, that processes it and then prompts it, could create structured JSON, which could then just be imported through the graph importer. This is, I say, is the low-hanging fruit because like it's halfway done, which is nice. And then if you're thinking, well, hold on a second, what about the hallucinations? You can validate these things with guardrails. Like it's not that hard. Moving right along, transitive search. Transitive search, I picked this name, by the way, because the way that I was thinking about it was like related search results, but there's already a related search filter, but it's not actually a filter. It's like the thing that shows you the D3 graph in the search interface. So I was like, okay, what communicates the operation here that doesn't have the word related in it? It's like, okay, transitive, right? I'm filtering on a set. I'm creating one set of search filters, and I'm basically saying, yeah, and now show me what's related to that. Transit through this set to these graphs. So I'm going to talk a bit about this. Elasticsearch has limitations here. For example, there's a reason why the relations index was deprecated. You may have only a few relationships from a resource to another resource, like on your resource instance node, but you could have like thousands or millions of relations from other resources. Like in this screenshot here, my example is a police agency, and the police agency is related to all of the individuals who are employed by that agency. And so there are limitations to how much data you can actually store in an individual document in Elasticsearch. So it's a problem that I've been really interested in because it's such a rich data set that isn't leveraged in search. And I heard that Cyrus is going to be talking about this as well, maybe. Okay, great. So it's a really interesting problem. specifically bidirectionality, right? It's one thing to say, show me the resources that are the sort of endpoint of a resource instance tile data. It's another thing to say, and show me everything that points back here. So I saw it as an opportunity because I thought there's got to be a way. And now I'm going to risk my credibility and do a live demo. Okay. Let's see. So you can see, let me make sure I have what I want. So if you don't know, you can now basically use a completely different search view just by keying in the keyword search dash view in search, by the way. Okay, so I have a search that I've already sort of preloaded. And the search is very simple. It's an advanced search filter on a node called LLM summary on a data model called PageRange. And if you're curious about what that is, it looks like this. It is an LLM summary of a PDF document, specifically a range of pages within that PDF document. And so in this example, I'm searching for the term skelly. This has specific meaning because it's a type of investigation implying that the police officer has done something wrong and they're being investigated for it. And so I searched here, I searched to find the documents that mention this word. And I'm thinking, okay, yeah, that's interesting. I have all these documents, right? But what I really want to know is, well, what are the agencies implicated, right? What's that? And so what I can do now is I can copy this search argument here. So it's telling search, okay, now I want to pivot. I want to use this search view called transitive search view. And I'm going to pass it a graph ID. Right, and the graph ID corresponds to the graph that I want to know whose instances are related to this search result set. And so let me make sure I have the and in there. Do I have an and? Yeah, I do. Awesome. So I'm going to paste that in, and I'm going to pray that this works, and it did. So full disclosure, the front end is not fully baked out. I've mostly been using it as a back end, but this is the exact same search, except now we're seeing the instances of this graph that are related to that result set. This is something that I'm using in a project that's like super useful, and it's not limited to just one graph. You could have a list of graphs, and you can export them. Yeah, I don't know, based on the silence, I don't know how useful it is to other people, but I love it. And back to my slides here. So that's what I copied in there. So looking into the code a little bit, if you're familiar with the search view Python class, you'll know that it has this method called execute query. I created an additional method here to execute a follow-up query. So basically, first I've done my search using my advanced search filter. And now what I'm doing is I'm grabbing those results and I'm saying, okay, find me the things that are related to this result set. And I'm showing you this because it comes back to the question of bidirectionality. It's one thing to say, okay, I can store, let me go here actually. This is the modification I made to the core arches index mapping. So I've got a nested object here. It's called from relations. And this is kind of duplicative with the resource instance data. So I'm saying, okay, what are the tiles effectively that live in a resource instance node that are on this instance? And it's basically straight out of the resource x resource table. But then I've got this other mapping called the two relations graph IDs. And this kind of lazily approaches the problem of, I want to know what other instances are related to this instance, but I don't want to store all of their IDs. I just want to know, first of all, does this have any related instances? And second of all, what are their graph IDs? And so what this does is it lets me first grab the IDs of the sort of direct relations, and then I can have a much more straightforward filter, smaller scope, filter for the relations that are sort of coming from another resource. And you can see I have this really lazy print statement cutting off at 10,000 IDs, because there are limits. Okay, that's, man, I'm moving through this fast. That's my transitive search view. Now I'm going to talk about arches for police transparency. So the project that I work on is called the California Police Records Access Project. Like I mentioned, it lives under the Berkeley Institute for Data Science at the University of California, Berkeley. It's also part of a consortium. Sorry, let me skip ahead. These are all of the other universities and groups that work with our project. So like lawyers, journalists, other technologists. It's a really awesome project. So the core problem that we're trying to solve is that we have police who have been investigated for wrongdoing, and there are documents that up until recently were not publicly available. They were not available to journalists. They were not available to victims of police violence. They were not available to anyone. It's a wonder that they existed at all. But because of some recent laws, we had access to these documents. So in this example, I have a screenshot of an investigation into a police officer where it was found that they falsified the police report. And this is their superior writing this in a report, super official. And there he is. That's the guy who falsified the police report, who is currently a practicing attorney in the city of Sacramento, California. And he faced absolutely zero consequences for his actions. He went on to work at a different police department where they had no idea of his prior record. And then he went to law school and became a district attorney, associate district attorney. So this is the problem that we're trying to solve. There is a complete lack of transparency in what police are doing wrong, and we're using a bunch of cool technology to do it, including arches. And by the way, this is a really great article that my colleague wrote about how, kind of similar to the way the Catholic Church has handled priests, basically police departments just shuffle around their officers. And there are these weird agreements where they agree not to, tell someone else's employer, yeah, you did this wrong, if the police officer just leaves without a fight. So just a bit of overview on what our process looks like. We request these records. We extract data using LLMs and other traditional algorithms. We organize this data into cases, including misconduct, use of force, and then we kind of go back to the extraction process, and then we go back to the organization process, and then we go back to records request process. Here is a demo. So I'm going to show off a plugin that I made that I'm calling Sheets View. The use case here was my teammates said, we really like spreadsheets. It's like, okay, but like you need to get out of Excel, you need to get out of Google Sheets. Like let's use a database. And so they said, okay, well, can you make it so that we can keep working in spreadsheets but in arches? So that's what it is. Yeah. So basically, each sheet will generate an output for an instance of a model called an agency. And so an agency is related to a bunch of other models. And what's interesting here is that it's one unified spreadsheet, but it's actually, there are sort of related instances here. What's very interesting for this group, I think, is that I have an advanced search filtering functionality here. So for example, I have this node called a source file, and the source file is a resource instance node. And typically in advanced search, you can say, show me something that is related to this resource instance. Well, if you don't know the full name of the resource instance, it helps to be able to just type in a part of it. So if I say the source file must contain the phrase, and I can enter in a partial name, so like OIS, that means officer involved shooting. And so here we have a filtered view based on that node value, which is, I don't know, I think it's cool. And then in addition to that, I've also got node value based sorting. So for example, I can sort on this one, extracted officer names. It was a descending sort apparently. And these, I didn't implement this as like a super custom thing. I implemented as just another search filter. So a custom sort filter that could be used with any other search view. And then take it a step further. Well, I see this data and I see that this is ineligible for organization status. That's not right. I'm going to edit that. So I have some just front end validation here. I'm going to say this is actually eligible. I've got some responsive styling here to signal that somebody needs to do something with this row. I'm going to save this edit. And I'm going to go down here and maybe I'll make one more edit. I'm going to link this to what's called a provisional case. So that's a resource model that is a resource instance node on another model. And so I'm going to say, I think it's like XYZ. It's basically a resource instance lookup. I'll do this XWV. So I'm going to link that. And there's a bug here, and it's not letting me save edits. Oh, that's what I got. Anyhow, that's that. One quick thing that I want to show you that might be of interest as well is for users who do not have access to the graph designer, I was thinking, it might be helpful for them to know what is the shape of the data, right? And so here they can explore just a sort of digested view of the graph. So what's the name, what's the data type, maybe the ontology class, maybe they don't care about that, and whether it's exportable. So they can expect to see it in their CSV when they export it. Yeah. And that's my demo. So what I was using was prime view data tables. Everything was server side, the filtering, the sorting, the searching. I didn't demo this, but you can actually do multi-sort in prime view and also in my custom sorting filter. You can do multiple sorts or sort on multiple node values, which is pretty cool. And that's all I got.
Thank you. Sure. Yeah. Questions? First one.
So, Galen, that was really great. As an aside, 3 lightning talks, great idea. I could ask a bunch of questions. I'm going to limit myself to just the one that I think is, for me personally, most interesting. And that is with your natural language processing example. Super cool. The what am I trying to say? Thank you.
Disambiguated.
Yeah. When you want to do that for a term like temple in your example, that could be either related to a control list or in a name or maybe in another model. What's the process for doing that? Like how do you tell the algorithm that you really only want to be looking at it in one particular location?
Yeah, so you can pre-process the natural language request by doing a search against concepts, right? So like specifically temple, right? You would search, this is kind of like a, pseudo rag. You would search among concepts for like, where is the word temple mentioned? And then tell the LM, hey, by the way, these concepts surfaced and these are the nodes that are using the concept lists that are using those concepts, FYI. That way it's like, it'll probably guess pretty well based on your graphs, like what does a temple mean in the context of a heritage asset, right? Versus a site or whatever. But you can help it along and do pre-processing.
And how sensitive would it be to a particular data set? Like, do you need to optimize for given like your knowledge about a particular data set?
How sensitive would it, what?
Like, so rules that you might use for one data set, would they work across multiple data sets, or do you really need to understand like sort of the corpus of the data to like tell the model how to like parse the?
No, you as an end user, no, you can be completely naive. Yeah, yeah. And one thing I thought about is basically like a little widget that sort of suggests common searches to give them an idea of like what questions can or should I be asking about this corpus? Like a little carousel of like, yeah, you can imagine.
Yeah, cool.
Yeah.
Thanks, Galen. This is awesome. On your transitive search feature, are you using Are you using the results from the Elasticsearch index to then kind of subset those results, or how are you interacting with the index to get from kind of the first stage of the searching to then the second stage of the searching?
Yeah, it's a great question. So the first stage, I am not getting paginated results. I am getting the entire result set, just the IDs. And then in the second stage, from that first set, I'm grabbing what are the quote unquote two relations IDs, and then what are the sort of from IDs I need to pair up with a graph based filter. So you can kind of see that in this sort of snippet here. It says query IDs dot extend. Here I'm basically saying, okay, I want to know, in layman's terms, I want to know what relations are related to these IDs from those graphs. And then I'm concatenating that result set with some data I'm getting directly from the search index.
Thanks.
Yeah.
Okay, well, thank you very much for that.